Hello students. Today some important concept I want to give you on circle. Some certain things are there that you need to remember while doing the circle chapter. Suppose it's a circle. It's a circle. For a circle, you know, a line joining any 2 points on the circle is a chord, you know. But whenever the same line passes through the circle, that becomes the secant. That you may or may not know, but please come to know. Here, it's a chord. Why? Now, any 2 points is joining. Here, suppose this is, we are giving A and this is B. It's a chord. Now, if we draw another chord, suppose here, this way. This is C and this is D. And they are meeting at a point P. So the question is, A and B is the chord, C and D is the chord. But what are chord segments? What are chord segments? Chord segments is little confusing for some students. But after today, no confusion will be there. See it. Suppose if any two chords, they are meeting at a point internally in the circle. So whenever meeting or intersecting, definitely they are, that means the chords are going to be divided into two parts. The chords are divided into two parts. We are seeing what are the two parts. Now here we are getting one. Suppose for CD, whenever it is intersected by P, then we can say it is DP and PC. Same for chord AB, whenever it is intersected by another chord at P, then we can say that means we are getting the chords in two parts, AP and PB. These divided parts are nothing but the chord segments. So here, just to facilitate the formula, we are writing here the given informations. So what we can write here, AB and CD are chords, and this PA and PB, PA and PB, as well as PD and PC, PD and PC are the chord segments. Chord segments. Product of chord segments are equal. AP into PB equals to PC into PD, PC into PD. So chord segments, this theorem is clear. AP into PB equals to PC into PD. Now, one question can come in your mind, that means whether for externally meeting the same chords, can we apply the same theorem? Answer is yes, we can apply. We can apply. Now see, here, if we draw the chord like this one, suppose this chord I am extending, and here another chord, here we are writing, and name we are giving, this is A, this is B, this is C, this is D, and this is suppose P, we are giving. So AB and CD, they were the chords, but when extended and meeting at point P, then AB is no more a chord. It has become a secant. AB has become a secant because now it is AP, and this is CD has become a secant and is known as CP as the secant. So what are secants? The secants are the lines which pass through the circle, So AB and CD, these two chords are meeting at P. So here AP and CP are the secants. So secant power rule, there is a theorem, and the same we can write is when the chords are meeting internally. And here we are writing when the chords meeting at a point but externally. Actually, it's not the chord segment. We can apply this same theorem. It's a secant and secant power rule. Here, this chord, it has two endpoints. One is A, another is B. Two endpoints. One is A, another is B. And this A to P, whatever the distance, A to P, that is AP, and another endpoint is B, B to P, BP, equals to C to P into dP. So I hope that means you can understand these chord segments and that secant power rule, or we can tell, that means according to ML Agarwal, you may tell whenever that means two chord segments are meeting internally or externally, the product of the chord segments are equal. That also you can tell. So here now the question can come in your mind, sir, how can you prove these two? Means how can I tell this one? So therefore this you need to know the chapter similarity. The chapter similarity, follow it. Suppose in this case, in a small way I am trying to prove it. Suppose if we join AD and CB, this angle equals to this angle because vertically opposite angle. At the same time, follow it, if we join DB, suppose, then we can tell this angle equals to this angle, because angles on the same segments are always equal. Angles on the same segment DB, that is angle DAB and angle DCB, both are equal. Then we can say this angle equals to this angle. For triangle APD, we can tell similar to triangle CPB. By angle axiom of similarity. This is why. Now since APD, angle APD equals to vertically opposite angle CPB. Another DAP, angle DAP equals to angle BCP. Axiom of similarity, angle axiom of similarity, we can tell these two triangles are similar. As these two triangles are similar, we can tell the corresponding sides are proportional to each other. AP, so this implies AP by DP equals to CP by PB. So from here we can tell AP into PB equals to CP into dp. That only we have done, cp into dp. So this one is proved. Same way for this, how we can prove? Can you tell? Can you think it? How we can prove? Here in this case, A and D we have joined. And similar way, suppose we are joining B and C. Now this angle equals to this angle. This angle equals to this angle. Why? Now BD is the same line segment. Because BD if we join, angles on the same segments are equal. This and this. That is BAD equals to BCD. We can tell. For triangle ADP and triangle BCP, angle P is common, and angle BAD equals to angle BCD. Since angles on the same segment BD are equal. That triangle ADP similar to triangle BCP using angle axiom of similarity. I could give you the formula only, but I am trying to show you so that you can recall the similarity theorems also at the same time. I hope you are understanding this concept. So as we have proved that these two triangles are similar, then corresponding sides are proportional. What are the corresponding sides we can tell? Suppose for ADP, AP we are taking. CP also. DP by BP. So what we can write? Now AP into BP equals to CP into DP. So that means theorem proved. AP into BP and CP into PD. Now one more I need to show you. One circle. Okay. In this circle, it's a tangent and it's a secant. They are meeting, suppose this is AB meeting at P and this is T. The theorem states that here product of chord segments. Please come to know this is the secant, but we can write the product of the chord segments. Here AP and BP. And thinking this chord is meeting externally with the tangent. When the chord is extended as secant and meeting the tangent TP. The product of the chord segments when the chord is extended as secant and meeting the tangent TP equals to square of the tangent meeting the external point from its point of contact. Now in the exam, this much of big under bracket as reason don't write. There in the exam you will write tangent space the secant property. Just this part you write down, tangent secant property. Here you can, according to that, we can tell that AP into BP equals to PT square. This is the property. Now let us prove this one. Let us prove. How to prove that this statement is true? Join A and T. Okay, now it's clear. So two triangles are formed. What are the two triangles we are getting? Two triangles here we are getting proof. Follow it. From the triangle ATP, from triangle ATP, from triangle ATP and triangle TBP. What we can tell? Now follow it. This angle equals to this angle. Many are thinking, sir, how? How is it, sir? You know cyclic quadrilateral? You know, suppose it's a circle, and whenever any quadrilateral is shaped like this, suppose whose four vertices are touching the circle or the four vertices are lying on the circle, then we can tell that quadrilateral is one cyclic quadrilateral. And in this case, cyclic quadrilateral, if one is extended, suppose we are extending it, then we can tell this angle equals to this angle. We can tell or not? This angle equals to this angle. Because that in case of a cyclic quadrilateral, suppose this ABCD is a cyclic quadrilateral. So in that case, we can tell angle CBE equals to angle ADC. Because here we can tell angle ADC equals to angle CBE. Since an external, that means an external angle of a cyclic quadrilateral, since an external ext dot external angle, just angle sign give, external angle of a cyclic quadrilateral, external angle of a cyclic quadrilateral equals to its opposite interior, int dot OPP dot int dot, we can write in the exam, its opposite interior angle. So it's the theorem. Therefore we can write angle ADC equals to angle EBC. Now how you are applying, sir? This is to no cyclic quadrilateral we are getting. Yes, we are not getting any cyclic quadrilateral, but suppose see this circle. Okay, now suppose this is the tangent, it is the tangent, and here it's a chord meeting the tangent. Then any triangle formed in the alternate segment, this is one segment, dekho, this is one segment, follow it. This is one segment, minus segment we are getting. Yes or no? We are getting one minus segment, and it's a tangent. It's a tangent. Suppose this is T and this is P. It's a tangent and it's a chord. Suppose AT is a chord and TP, and an angle we are forming. So from that minor segment, and it is this minor arc we are finding, and this is the remaining arc. So this angle will be equal to any angle formed by the triangle on the remaining part of the arc. Suppose here and here. So this angle and this angle, suppose this is C. तो देखो, this is called angles at the alternate segment, that is ATP equals to ACT. Not on this arc, it is forming on the remaining part of the arc. This circle concept is very, very important. Here, what is that angle at the alternate segment? देखो, angles at the alternate segments, remember, angles at the alternate segments are equal. Angles at the alternate segments are equal. What are the angles at the alternate segments? Now, whenever a chord and tangent making one angle is equal to the angle which is not formed on the same segment, on the remaining segment, on that any angle if is formed, that means suppose if we draw like that, this and this, then this angle also will be equals to this angle. Are you understanding or not? This angle will be also equals to this angle. Now our criteria or our concern is with the angles at the alternate segment. So what is that angles at the alternate segment? Whenever an angle is formed by the tangent and the chord, that will be equal to the angle which is formed at the alternate segment. That means here, suppose on the remaining part of the arc it is forming ACT, that equals to this one. Is that clear or not? So here what we can say here, angle ATP equals to angle, we can say ACT. So this formula, please remember, angles at the alternate segments are equal. This part. Okay. Now here follow karo. Here, suppose we are here, the same circle I am trying to draw here. Follow. And देखो, it's a big chord and it's the tangent, and this we are forming the angle. देखो, this is the angle, this. So this chord means this segment already is covered. Suppose covered, that means remaining part is this one. Now if any triangle is formed, then this angle will be equals to this angle. Yes or no? This angle will be equals to this angle. Take same way, suppose here any triangle if we form, then this angle will be equals to this angle. Yes or no? Angles at the alternate segment, this angle equals to this angle. Now already I said you, for one cyclic quadrilateral, now suppose this is M. So AMTB is a cyclic quadrilateral, ADCB is a cyclic quadrilateral. Now this, an exterior angle of the cyclic quadrilateral is equal to its opposite interior angle, that is this angle equals to this angle. So now if this is the alternate segment, angles at the alternate segment, at the same time ABTM is a cyclic quadrilateral, therefore this angle equals to this angle. So angle AMT equals to angle TBP. So easily we can tell, if this angle equals to this angle, at the same time this angle equals to this angle, so 100% we can tell ATP equals to angle TBP. Matter is clear? Suppose this is where angle we are giving A, this is we are giving B, and this is we are giving C. Our first question was that why, sir, this is angle B equals to angle C you have written. This whole angle as B we have mentioned. Whole angle. Why angle B equals to C? I tried to prove. So for that I showed you the cyclic quadrilateral. I tried to show you the angles at the alternate segment. So from here, as we have already showed you the cyclic quadrilateral, so we can tell A equals to B. So angle A equals to angle B. At the same time, angle A equals to angle C and angle A equals to angle C. So what you can write? Angle B equals to angle C. We can prove or not? So this angle equals to this angle. Now for this triangle, though it is going to be little painful for you in understanding, but a close observation can give you the proper concept. So we can tell this angle equals to this angle. So one angle we have showed. Now another what I gave here, that means in this case from triangle ATP and triangle TBP, ATP and TBP. So this angle and this angle we have showed. Another more what? TBP and ATP, P is common and angle P is common. Therefore, we can tell triangle ATP similar to triangle TBP. TBP. I am not cleaning anything so that later you can understand. So these two are similar triangles. Whenever two triangles are similar, their corresponding sides also will be proportional. Angle means angle AA, axiom of similarity. And from here, what we can tell? PT by equals to AP, bigger one. And for the smaller triangle BTP, TP we are taking TP. So from here, we can tell AP into BP equals to PT square. So we have proved already this one. So this is the fact. These three concepts of circle and the similarity, what I tried to show you, can give you inspiration in doing the circle chapter and understanding any measure the angle or some specific they are telling, that means find the value of TP or something. Easily you can form the equation and easily you can get the value. So how is the class? That you please write in the comment section. And if you understand what I tried to make you, please give a thumbs up and share it with your friends so that this new channel can come up with the least expectation. So for the time being, bye bye.